A quote from Mike Brown, U.S. astronomer and Kuiper Belt expert. The Kuiper Belt is a deep, frozen record of the early history of our solar system. The Kuiper Belt is an icy region at the outermost edge of the solar system. NASA has now revealed new shocking details about what is really hidden in this mysterious and hitherto little explored zone. We need to be prepared for a lot, because the latest findings could prove that the history of our solar system was very different from what we thought. Strange objects in a previously unknown planet could turn our view of the world completely upside down. Was it a big mistake that we paid too little attention to this region for so long? The Kuiper Belt begins around 4.5 billion kilometers from the Sun and ends up to 7.5 billion kilometers from the Sun. It thus forms the outermost edge zone of the solar system. We have only discovered and explored a fraction of its astronomical treasures and peculiarities. Time and again, objects appear here that cause scientists concern. In terms of its width and mass, the Kuiper Belt is a gigantic band of ice, rock, and frozen gases that is up to 20 times wider than the main asteroid belt between Mars and Jupiter, and contains 20 to 100 times more mass. The Kuiper Belt region includes another bizarre phenomenon, the so-called scattered disk, a zone of irregularly distributed celestial bodies that even extends far beyond the regular boundaries of the Kuiper Belt. The light conditions in the Kuiper Belt are extremely weak. This region is so far away from the Sun that the few rays of sunlight that reach these distant objects only produce a pale glow. The light is barely enough to penetrate the icy darkness. This low level of illumination not only makes the Kuiper Belt extremely difficult to explore, it is also unusually cold. However, this extremely cold environment is just right to perfectly preserve all the primordial materials from which the bodies there have formed. Researchers assume that the majority of objects in the Kuiper Belt have not changed for billions of years. This makes this region an important window into the early days of the solar system. The Kuiper Belt is not only a place of darkness and cold, but also a dynamic zone where many dwarf planets such as Pluto, Eris, Haumea, and Makemake can be found. These objects offer unique insights into the chemical composition and physical conditions of the early solar nebulae from which our solar system was formed. In addition to the dwarf planets, there are countless other objects, including comets and smaller icy bodies that may contain important organic compounds relevant to understanding the chemistry of life. Probes have only visited and explored this remote area twice so far. Pioneer 10 made the first flyby in 1983, but did not encounter any specific Kuiper Belt objects during its mission. After the first detailed investigation of Pluto and its moon Charon, New Horizons flew further into the Kuiper Belt in 2015 and discovered, among other things, the strangest object in the solar system. Arrokoth, also known as Ultima Thule, is so misshapen that the object contradicts some physical rules. A time capsule of immeasurable value. Would you have thought that asteroids and comets are original relics from the first hours of our solar system? At a time when the Sun was just being born in an incredibly hot and rapidly rotating dust disk, other rocks and objects were already forming in the remaining primordial plasma. These objects have remained unchanged to this day in some regions of the solar system. Our previous research has shown that asteroids and comets consist of an astonishingly high degree of mineral and organic substances. These include, for example, magnesium, sulfates, iron, copper, and even amino acids, which also make up our DNA, for example. Organic substances are the building blocks of life. The soil on our planet, plants, our bodies, and much more would not be possible without these substances, and it is downright astonishing that they were apparently present in high density in the early days of the solar system. This does not paint a picture of a gradual emergence of living conditions within the solar system, but rather shows that life was intended from the outset, and that it is perhaps even rather unusual that there is only one planet with organic life in our solar system. If we take the idea a little further and consider the latest findings in astronomy and cosmology, we cannot currently rule out the possibility that there were also fertile phases with life forms on other planets. We suspect organic life on some icy moons, which are warm at depth and could harbor liquid oceans. Computer simulations have also shown that Mars may once have had an atmosphere and liquid water. And even on Venus, we cannot rule out a fertile phase with life. Precisely because we know so little about the past, contemporary witnesses, such as objects that have remained unchanged since the beginnings of the solar system, are of great interest to science. Research into the Kuiper Belt has only just begun. Welcome to the trans-Neptunian zone. It's now common knowledge that a whole series of new small planets have been discovered in the Kuiper Belt. Around 2,000 of these so-called trans-Neptunian objects are currently known. Pluto is the largest of these planets, and precisely because Pluto resembles the other trans-Neptunian objects much more than the other planets in the system, it had to relinquish its planetary status in 2006. Since then, Pluto has officially been a dwarf planet and bears the unappealing catalog name 134340 Pluto. Pluto was discovered in 1930 by the astronomer Clyde Tombaugh. There was great joy among people at the time. Another planet was an exciting thing. After Pluto, no new planets were discovered until 2005. It was not until 2005 that Eris appeared in front of the researchers' telescopes. Exploration of the Kuiper Belt began in earnest in the 1990s, but it took another 2 years before it was clear what and how big the Kuiper Belt really is. Between Mars and Jupiter, we have a similar area, the asteroid belt, in which around 1.9 million objects are bound. The asteroid belt was discovered because researchers suspected another planet there. Instead of a planet, over 1.9 million individual objects then appeared, which at times were thought to be fragments of a shattered ninth planet. However, such assumptions have not yet been confirmed. In fact, researchers have also been searching for another planet in the Kuiper Belt for several decades, the 10th at the time, and now the 9th after the degradation of Pluto. Some astronomers are of the opinion that there must be another larger body behind Neptune, somewhat larger than our Earth and a little smaller than Neptune. So far, the legendary Planet 9 has not been clearly confirmed, and research into whether it really exists or not is still ongoing. The reason for this assumption is the orbital anomalies of some smaller planets in the Kuiper Belt, which can best and most coherently be explained by the existence of another planet. Certain irregularities in Neptune's orbit could also provide clues. It's amazing how researchers have been intensively studying our outer solar system for around 100 years. Since that era, we have had telescopes that allow a clear view of this dark area. But although the telescope's reach easily extends to the Kuiper Belt and beyond, it's the light that often thwarts researchers. For example, it is easier to study our nearest stellar neighbor, Alpha Centauri, with telescopes than the comparatively much closer Kuiper Belt. Invisible objects such as planets or even entire clusters of smaller objects, such as in the Kuiper Belt or the asteroid belt, are usually first noticed due to the gravitational force they exert. Researchers then calculate approximately where one or more other objects must be located, and then they set out on a targeted search. Such gravitational anomalies led Gerard Kuiper, who gave the region its name, to assume back in the 1950s that there was much more to be found beyond Neptune. Many unknown objects in the scattered disk. Hardly anyone knows about another region of the solar system that researchers refer to as the scattered disk. This fascinating and enigmatic region of the solar system is partly connected to the Kuiper Belt, but also extends far beyond it in places. The disk-like zone begins roughly at the outer boundary of the Kuiper Belt and extends several million kilometers further out into space. Some of the objects in this region have orbits that take them up to 150 million kilometers away from the Sun. Due to this enormous extension, the scattered disk is one of the most distant regions of our solar system and even less explored than the Kuiper Belt. What is striking about the objects in the scattered disk is the high eccentricity and inclination of their orbits. These unusual orbits are probably the result of gravitational interactions, especially with Neptune. As the large gas giants of our solar system took their places in the system, their powerful gravitational fields perturbed the orbits of many smaller, icy objects. Those that were close enough to be affected by Neptune's gravity, but not ejected from the solar system, found themselves in the scattered disk. Presumably, the scattered disk serves as a kind of reservoir for comets, and some of these objects are periodically attracted to the sun and then occasionally enter the inner solar system. A well-known comet that presumably originates from the scattered disk is the comet Hale-Bopp. This comet became famous after its spectacular appearance in 1997, when it was visible to the naked eye from Earth for many months. Hale-Bopp is classified as a long-period comet whose orbit takes it far into the outer reaches of the solar system. Its orbit has a very high eccentricity, which is typical of comets, which come from the dispersed disk. This object takes about 2,500 years to orbit the Sun. Anyone who saw Hale-Bopp in 1997, therefore, witnessed a truly rare visit. Scientifically, the scattered disk is particularly interesting because it provides information about the dynamic processes that have shaped the outer solar system. By studying the composition and orbital paths of all the objects in this zone, astronomers can draw valuable information about the movements of the planets and the early conditions of the solar system. It is certain that our solar system has not always looked like it does today. It probably took many millions of years for all the objects to fall into place and for the orbits of most planets to become so stable that order prevailed in the system. Imagine what it must have been like when planets were still jockeying for position in the system and many more asteroids and comets were hurtling through the system. Back then, collisions were even more frequent, and our Earth also experienced times when it rained comets from the sky. Some researchers are even of the opinion that this is how water and ultimately life came to our planet. Comets consist largely of ice, and their organic components could make them truly heavenly messengers of life. However, it's still a mystery where the first impulse for the emergence of bacteria came from which ever more complex living beings then developed in the course of evolution. Subscribe now and never miss a new video.